Hi everyone. Now we are going to discuss about the VI characteristics of the IGBT. So in the VI characteristics of the IGBT, we are going to talk about the transfer characteristics as well as the output characteristics. Coming to the transfer characteristics, this is going to be plotted either between the drain current and the gate to the source voltage, or the collector current and the gate to the emitter voltage. Both is going to be having a same sort of transfer characteristics. So for some extent they are not non-linear, and then after application of the threshold gate to the source voltage, they are going to be linear here. So now coming to this transfer characteristics, when we talk about this ID versus VGS, so it is going to be explained for an N channel type of IGBT. The drain current ID is a function of actually gate to the source voltage VGS, and the curve is reasonably a linear in most of the drain current when the gate to source voltage is greater than the threshold voltage. So when this gate to source voltage is greater than the threshold voltage, we have observed the linear characteristics for the curve. So but this curve is non-linear when the drain current is lower than the gate to source threshold voltage. So when the gate to source voltage is less than the threshold voltage, so then it is going to be a non-linear. So now if the gate to source voltage is less than the threshold voltage, what happens to the current flowing from the drain to the source is about 0. So the value of the gate to threshold voltage for the IGBT is about 2 to 3 volts. So while ID is equal to 0, so when the drain current is equal to 0, so then the drain to source is open circuited, the drain to the source is open circuited, and then IGBT operates in the off state, and the device should able to hold the supply voltage of VDD, the value of the voltage which was going to be held during the off state. The supply voltage was VDD. So now when the gate to source voltage is less than this threshold voltage, there is a no inversion layer, that is no depletion layer, which is going to be not depletion layer, the inversion, the N channel element is not going to be created, but which connects between the drain to the source. Consequently, the drain to the source is open circuited and the applied voltage is dropped across the junction, and a very small leakage current flows. At that time, IGBT is going to be operate in the off state. So now, it is very clear from this characteristics that the drain to the source breakdown voltage must be greater than that threshold element to keep away from the device breakdown. So if the drain to the source voltage is greater than the drain to the source element, so the IGBT will be breakdown due to the avalanche breakdown of the drain to the body junction. So that is going to be happened with the help of this transfer characteristics. So now coming to the case of the output characteristics. So coming to the case of the output characteristics of the IGBT, so they are like this. So the output characteristics are also going to be considered either collector current to the drain to source voltage, or the collector current to the collector to emitter voltage, like this. Same how we have considered the characteristics for the case of the MOSFET, similar output characteristics almost are going to be observed here, but actually these are the characteristics same like a BJT. So BJT like characteristics we are going to observe here. The output characteristics of the N channel element. So here how we are going to consider it was, so coming to the characteristics, VI characteristics, in case of this we are going to have three regions which we observe here. So one is an cutoff region. So when your gate voltage is less than the gate threshold voltage, then what we are going to observe was we are going to have a cutoff region. So and then when we are going to have this is going to be a on state region, and this is going to be a active region part. So now as we keep on increasing the value of the VDS, so or the collector current, as we keep on increasing, it is going to be get increased for some extent, and after this on state region it is going to enter into the active region, and here it is going to be gets breakdown like this, right? So we are going to have the VI characteristics like this. When the IGBT is operate in the off state, the junction, so in the case of cutoff region, off state region, so what happens to the IGBT was the junction J2 blocks the forward voltage, then IGBT has the reverse voltage blocking capability. The reverse blocking voltage of IGBT will be equal to the forward blocking voltage when the IGBT is manufactured. So during reverse bias condition, the junction J1 behaves as a reverse blocking junction when it is going to be operated in the forward bias condition. So when this until this gate to the source threshold voltage was reached, so it is going to be having a forward breakdown. So this is going to be called as a forward breakdown region. So and this is going to be called as a reverse breakdown region. So this is the VI characteristics of an IGBT, and which can be considered as a output characteristics of an IGBT. Thank you.